Why does a magnet snap onto your fridge but do nothing to a wooden table? Why can electricity suddenly create a magnet inside a motor? And how do giant power plants use spinning coils to create electricity for entire cities? To understand all of that, you need to see magnetism for what it really is, the invisible dance of moving charges. Take a needle and rub it several times in one direction with a magnet. Place it on a small piece of paper floating in water. The needle slowly turns and points north. You just built a simple compass because rubbing it lined up tiny magnetic regions inside the metal. This is the Learning Studio, explaining the world without confusion. A magnet works because its atoms have tiny internal magnets called magnetic domains. In normal materials, these domains point in random directions, so their effects cancel out. But in magnetic materials, many domains line up the same way, creating a visible magnetic force. That's why only certain materials can become magnets: iron, nickel, cobalt, and some of their alloys. Wood, plastic, and fabric don't have domains that can align. A magnetic field is simply the region around a magnet where it can push or pull something. We draw this field using lines that go from north to south outside the magnet. Where the lines are close together, the field is strong. Where they spread apart, the field is weak. But here's the deeper truth students overlook. You don't need a permanent magnet to create magnetism. Running electricity through a wire instantly creates a magnetic field around it. Loop the wire into a coil, the magnetic field becomes stronger. Add a piece of iron inside, the field becomes massively stronger. That's called an electromagnet, the heart of motors, generators, cranes, speakers, transformers, everything. Motors work because electricity creates magnetism, and magnetism creates force. Generators work because spinning coils in a magnetic field create electricity. Transformers work because changing magnetic fields induce voltages in nearby coils. Magnetism and electricity are not separate. They're two faces of the same phenomenon, electromagnetism. Here's the intuition. Permanent magnets give you a steady magnetic field. Electric currents give you a controllable magnetic field. Changing magnetic fields give you electricity. This loop powers modern civilization. Now think about this. If moving charges create magnetism, what happens when the magnetic field itself begins to change? Can a magnetic field create electricity out of nowhere? Yes, and that's the secret of electromagnetic induction. We'll break that next.